I'm Kirk Harnack. On This Week in Radio Tech, I'm joined by Chris Tarr and Tom Ray. We're talking about earthquake warnings, Chris Tarr's big red button, and the General Radio sexless connector. TWiRT is up next.
Netcasts you love.
From people you trust.
This is TWiRT.
Bandwidth for This Week in Radio Tech is brought to you by CacheFly at CacheFly.com.
This Week in Radio Tech, episode 96, recorded August 24th, 2011. Big red button. This Week in Radio Tech is brought to you by Omnia Audio and the hugely popular Omnia One processor. Get your free 5-band FM upgrade today at OmniaAudio.com. It's time for This Week in Radio Tech. Hello there, I'm Kirk Harnack. I'm really glad to be with you and glad that you've joined us. If you think this show is all about geeky stuff, well, you're absolutely right. I've got two co-hosts here on the show with me on this episode. We have, first of all, from the Hudson Valley of New York, let's check out Tom Ray in his ham shack. Hello, Tom.
Greetings, Kirk, and how are you doing this evening?
I'm awesome. What's on your head?
It's football season. Giants are playing the Jets Sunday. Come on.
Okay. All right. So who are you rooting for?
I'm a Giants fan. My son's the Jets fan, and unfortunately, he's in Phoenix right now visiting his grandfather because, I say unfortunately, because we've made it kind of a yearly event where we go to the Giants-Jets preseason game and argue the whole game. It's great.
All right. Well, Tom, you're the big kahuna engineering-wise over at WOR, big 3-station 50-kilowatt blowtorch in New York. Is that all you do?
Well, not actually 3-station, big 3 tower. We probably have the greatest amount of vertical real estate in the New York market. But no, I'm the VP of Engineering for Buckley Broadcasting and responsible for our stations in California and in Connecticut, and take care of WOR. And I'm a ham radio operator, and I do TWiRT, and I do all kinds of other things too. So I'm glad to be here as always.
And you're a dad and a husband and all that too. Well, we're glad to have you on. We're going to hear from you about this really interesting sexless RF connector. Ooh, did I just say sexless on the TWiRT network? That's going to be interesting.
Yes, you did.
Let's swing the camera out and zoom in on Mukwonago, Wisconsin. Hello, Chris Tarr.
Hello there. I just figured I'd bring up what a real football team looks like. Notice the logo there on the side.
You're just
right
green
there
with envy. You're
Super
green.
Bowl, Super Bowl. There you go. So anyway.
Hey, excuse me. We were Super Bowl champs before you were, okay?
And how many have you had compared to the Packers again? I never mind.
I have no idea, but you guys don't have ticker tape parades.
You've never been to Green Bay. I can tell you that's not true. I am the director of engineering for Intercom's radio stations in Madison and Milwaukee, Wisconsin. I also run the site Virtual Engineer, which is broadcastengineering.info. And I also write a column that appears in Radio Guide magazine as well.
Cool. Awesome. Well, and Kirk Harnack here, yours truly, your host, is the Director of Sales and Marketing for Telos, Omnia, and Axia. And also I'm part owner of some radio stations in Mississippi and in American Samoa. So there you go. I have a little bit of qualifications here, but usually we're talking all over our heads here. Hey, we've got a show here that today is sponsored by the folks at Omnia Audio. Just a quick plug. I want you to check them out at OmniaAudio.com. And if you would, check out the new Omnia 9 processor and the Omnia 11. I'll be telling you more about those during the commercial break-in and making you an offer to sign up for the catalog that is free of charge. Okay. We got a few items on the agenda today, and the most timely one is probably this earthquake that happened in Virginia and really shook the Washington, D.C. area. And it's my understanding that there was no EAS warning of any kind fired off by radio stations in that area. I don't think that's a bad thing. What's EAS going to do? But I want to hear from Chris and Tom about on this subject. Do you fire? Now, normally, by the way, EAS is something that is not initiated by a radio station. An EAS warning is something that is initiated by a government agency. So none was issued that we know of. Tom, you're in a big city there in New York. What if you had an earthquake in New York? Would anybody be doing something with EAS?
Well, probably not initially. Just so no one gets the wrong impression, a radio station can issue an EAS alert warning if it is warranted. But you're right, it normally comes from the civil authorities. EAS primarily is intended as an early warning system, or and with an earthquake, I don't know. They really haven't perfected how to tell when the earthquake is coming yet. There's usually no warning. Where it would be appropriate, in my mind, for for something like an earthquake would be maybe after the fact, if there's a reason to get out of an area, let's say a gas area, that would be an appropriate use for EAS during an earthquake. But after for example, after the thing went the other day, I mean, people left buildings and people, they evacuated City Hall, and 5 minutes later, everybody went back to what they were doing because there was no imminent danger. So there was no need to activate EAS. So I don't know how useful it would be for an earthquake, unless we knew it was coming, or unless there was something after the fact, like that gas main break I used in that example.
By the way, I'm told that most EAS units, or at least some of them do, like the Sage NDEC, does have a code for an earthquake, a EQW. A lot of three-letter codes for the different kinds of warnings, whether it's a tsunami or a tornado warning or something like that. Chris Tarr, what do you guys do there in the flatlands? If you had an earthquake, or what kind of things would you or wouldn't you use the EAS for?
Well, I do have that code programmed into our EASs to forward if it ever happens. But I agree mostly with what Tom said. EAS primarily is for either warning or for disseminating information after the fact. So, the earthquake warning, there's really not. I can't think of anything appropriate for that. I think you very well though could justify afterwards. The emergency management wanted to use EAS for civil information, and those codes are programmed into EAS as well. They can trigger that if there's information for shelter, if there's information for just general safety information. That is also programmed in as codes in EAS. So I believe that that would be appropriate. And somebody mentioned in the chat room here about tornadoes in Wisconsin. We get a lot of tornadoes out here. So, we do use a lot of, especially in the summer, our EAS is pretty active. But again, a tornado, we know generally within, it may only be a few minutes, but we generally know that there's something on the ground and coming our way. So in that case, it's very helpful. In the case of an earthquake, I don't know that there'd be a lot of early warning, but I do think there would be perhaps afterwards, especially in an area that doesn't experience that very often, possibly using it for emergency information.
I'm guessing that, Chris, in your area in Wisconsin, you probably don't have the tsunami warning program then as a real priority.
No, that's what I don't think I have in my boxes. As a matter of fact. In the chat rooms, Knox Harrington mentioned that, hey, the one time he was in a tornado, he got the EAS warning for it 15 minutes after the tornado had occurred. Now, there's a couple possibilities there. It is possible that stations have programmed their box incorrectly, or maybe I should say poorly, to delay or wait before they pass something along. Certainly a tornado warning should not be something that gets delayed ever. That should be passed along right away. It's also possible that the tornado occurred. It could have been a different funnel. I don't know. I'm sure Knox knows what he's talking about in the chat room here, but it could have been a different funnel or a different warning issued by the National Weather Service. And as radio stations typically don't have a meteorologist there, go ahead,
Kirk. You're a meteorologist. Wouldn't, if I'm not mistaken, a warning is an event that has occurred, so the tornado has been spotted before that is even issued by the National Weather Service, if I'm not mistaken. If it hasn't been spotted, there's a good probability it's going to happen that they've noticed on the weather radar. So it's not inconceivable that warning came in late.
Well, here's something else though, and I run into this even. It's actually kind of timely because this week we put in our digital EAS boxes. So I was working with the program directors. You'd be surprised how many program directors don't want those alerts to auto forward. We do, and our stations are LP2s, so we really need to because other stations monitor us for that information. But you'd be surprised how many stations put their box in manual and don't forward these alerts until they time out, which is, by the way, usually a 15-minute window. So it's certainly possible that that somebody had programmed in their EAS box to not auto forward those messages, or it set the box configuration not to do that. Now, I think personally pretty irresponsible, and I think probably the FCC would see it that way too. But there's not a whole lot of guidance on what you must absolutely forward, and what doesn't need to be forwarded. We usually rely on our state EAS plans for that.
Yeah, and we're set up to auto forward a tornado warning. I mean, it happens immediately while it's still coming in. But some of the older boxes, EAS boxes, if another warning came in after the fact, and we had this happen the other day, we did have a tornado warning come through, and in master control, the old box is still in effect, or it's still in line, and they wanted to forward it. But immediately after the tornado warning, a severe thunderstorm warning came through and negated the tornado warning. They couldn't send it. The box would not allow them to send it. So we ended up grabbing a news guy and having him read it on the air.
Sure. Yeah. Wow. Well, the system, no matter how hard you try to make a system work and work perfectly and save lives and warn people, there's always ways to mess it up, whether intentionally or unintentionally. I say intentionally because if you've got your tornado warning delayed 5, 10, or 15 minutes, well, that's just silly when something as serious as a tornado is in the area, in the near vicinity. But they can be messed up accidentally, like you just said. If you get something superseded by something less important, well, gee, many. All right, well, I think we're all in agreement that some things you just can't warn about, and EAS may not be the right thing to do. Now, if it was extremely widespread and severe damage, you might use EAS as an alert to tell people where to go, what to do, to get out of the path of something else happening. Let's imagine there was radio during the great San Francisco fire of 1906. You could use EAS to warn people about the fire, right? If they didn't already know about it. Well, next in the news, Toyota has announced that it's going to be putting HD radio in their 2012 Camrys as an option with their higher-end sound system. Well, this is great. I did notice that in their announcement, they're also offering Pandora and a couple other services as well. I think you have to you supply the cell phone data connection. I don't know when they're going to get around to supplying that 4G in the car itself. But anyway, I guess that's good news. HD, it can come with the car and a Toyota. I think it's the first time for Toyota. And that brings up the question of, I know we can argue all day long about is HD doing us any good or not, but we can at least remind ourselves of good engineering practices for HD, good audio processing practices. Are there practices that are involved with keeping the transmitters going? And let's turn this over to Chris Tarr. Chris, I want to hear, you've had some HDs on the air for a while now. In the time that you've had them on the air, what kind of maintenance or engineering, what kind of things do you tend to look out for now on a regular basis to keep your HDs working well and sounding good?
Actually, that's pretty timely too, because I'm working on my capital expense reports for or predictions for next year. We're going to be doing some upgrading there. But I've had HD installed since I believe 2004, late 2004 into 2005 is when I put mine in. So they've been there quite a long time. The one thing that we find with HD at a lot of our stations and a lot of my competitor stations is, we didn't build a lot of redundancy into the system when we put it in. I mean, it's a pretty expensive proposition to begin with. So, we are seeing the upside is that generally HD transmitters are brand new. So, we have the benefit of these transmitters working pretty well. Even still, they're very early into their lifespan. So, other than a few module repairs here and there, the transmitters themselves are reliable. But the other side to this that we're finding is, hey, guess what? These transmitters are run by computers. Those don't have a limited lifespan. So, we're dealing with a situation now with the HD exporters. The original versions, like the ones I have, use a spinning hard drive, a mechanical hard drive. Well, those are now 7 or 8 years old. those hard drives, and they fail. And more than once a month or so, I'm having to reload the software on there to keep it running just long enough to work on what I'm working on now. Is a new version of the exporters have solid state drives. They don't have moving parts that wear out, so they're a lot more reliable. So we're finding things like that are really the issue. Things like importers and exporters that are computer based that are having issues. And those are really, what's coming back to bite us now. And I think the other thing that's coming back to bite us is in some situations, there's a lot we didn't know then that we know now. For example, how important it is that the load is proper to the reject load. Any impedance changes there can result in spectral regrowth and things like that. And we're finding that a lot of people bolted HD onto a bad performing RF system, or an RF system that wasn't very good to begin with, and the performance isn't very good. And so then we've got some people going, yeah, HD doesn't work at all. It's interfering and it's loud, it's noisy, and it does. Well, they didn't do their homework when they put it in. And there's just a lot of things we didn't know. When I first put HD in, we weren't doing multicasting. It wasn't even, it was talked about, but it hadn't been released. So, now there's how do we divide up the bit rates and things like that. So, long story short, well into the lifespan now, we're finding that transmitters are doing pretty well. We're not really having a lot of issues with those, but it's a lot of the ancillary stuff that we're seeing has a limited lifespan, especially if you were an early adopter.
One other thing I was wondering about, Chris, and Tom can address this too from the AM perspective. This notion about spectral regrowth that you mentioned, and just how robust is an HD signal, especially what kind of things affect it? Transmitter tuning, or a poorly performing antenna, or some kind of VISWR problem with the transmission line, or something not set up right in the HD exciter. What are some of the gotchas, or what are some of the things that you maybe monitor to see or try to determine if your HD signal is as robust as it should be? Is the data being transmitted as quality as it should be? Chris?
Well, I mean, obviously, we use things like Automat has a great box, the Golden Eagle, that has a built-in spectrum analyzer. Use that to check things at the source. But really, in terms of quality, really all you can do is kind of a comparison over time. I do a lot of driving around monitoring the signals and seeing how they perform. And we also have a real interesting situation here, which actually I guess it's not interesting out east, but here out east it happens a lot. But we've got a lot of short spacings being so close to Chicago, and so it's a real good way to test how HD is performing. And I can tell you that our HD system was put in with a fairly new RF system to begin with, fairly new antenna, transmission line. Our first adjacent in Chicago was a very well run plant, very well built, and we don't really have any problems with our two stations' HD sidebands interfering with each other or causing any problems. So, there's a lot of that kind of thing going on now that. Now that we know a little bit more than we did then when we put them in, there's a little more tweaking with things like, bit rates and even carrier levels. Now there's new things where people are placing more energy in one sideband than the other to mitigate interference if there's an issue there. So, there's a lot more things we know now that can improve the performance of the HD system that we didn't know then.
Tom, how about you with AM? What issues do you have, and how do you keep things running so that your data is good and people can pick it up as far out as it's intended to be?
You mentioned VSWR, you mentioned antenna system performance, you mentioned transmitter performance, transmitter tuning. All of the above can affect that. The nice thing about some of the newer transmitters, like the 3DX50's WR uses, there's no tuning adjustments. I mean, they just don't drift. There are, however, a lot of internal adjustments on the electronics in the transmitter that could affect the HD signal, but I generally run I've got a spectrum analyzer at the transmitter site, and every time I'm over there I fire the thing up and take a look at it, and I can pretty much tell if something's going slightly out of whack, particularly with the antenna system. We keep an eye on the common point. If I see the impedance bridge start kicking up, I can either make an adjustment to that or check it on the spectrum analyzer. with AM, you've got the spectral regrowth that'll show up plus or minus about 25 kilohertz on either side of the carrier, and that correlates directly with data errors. So if the spectral regrowth starts coming up, you're going to have a lot more data errors. If the more data errors you have, excuse me, the less HD coverage you're going to have, because the farther out you get, of course, the more noisy the signal will be. And when that happens, you're going to start getting dropouts in the HD signal. One of the things a lot of people who set up an AM HD initially failed to do, or not failed to do, the mistakes they make, they set the spectrum analyzer up for the wrong settings. That's number one. And number two, they don't take enough time to set it up. When you set up an AM, you need to set aside at least 2 hours, if not 3, because you have to do an awful lot of sampling with that spectrum analyzer and let the whole thing settle down to get a good reading. Make an adjustment, do it again. Make an adjustment, do it again. It's very tedious. But I had a guy call me once. He had a six tower array with the AM, and he called me. He says, I get a mile away. I can't hear it. I says, well, how'd you set it up? What were your spectrum analyzer settings? He gave me the settings. The settings were wrong, and he spent about 15 minutes. And I said, no. Here's the settings. Go back and do it. Spend about 2, maybe 3 hours, and just sit there and rock that thing in and get it right where you want it. And I told him exactly what to look for. And let me tell you, he called me back the next day. He says, this thing goes forever. He said, it's unbelievable.
I thought AM stereo took a long time to set up, and there were a lot of iterations, to close the loops on all the phasing adjustments, to get the transmitter and the antenna tuning unit rocking just right so that AM stereo worked well. By the way, somebody in the chat room asked, is AM stereo compatible with HD? And I think the answer is no.
No, you're correct. The answer is no, primarily because with AM stereo, the stereo information is carried on the phase of the carrier. It's a phase-modulated signal. With HD radio, the stereo information is phase-modulated, and that'll just blow the AM HD right out of the the AM stereo right out of the water. Plus, you have to have a 25 hertz pilot tone you're transmitting with the AM stereo, and that's going to cause grief for the HD and vice versa. So it's really not compatible. They can make a radio that has AM stereo and HD in it, decoders in it, but transmitting both at the same time doesn't work.
Yeah, gotcha. So can you tell us a little bit more about what you said? You have to have the right settings on the spectrum analyzer. So typically those are the number of hertz per division or kilohertz per division, and there's also the resolution bandwidth, right? The resolution bandwidth of the sweep as it goes across. Can you enlighten us a bit on why people get it wrong and what the right settings would be and why?
Well, a couple of reasons they get it wrong is, number one, they may not really be familiar with the spectrum analyzer. That's number one. Number two, they're just trying to do it the fastest way possible, which for some things works, but in this case it doesn't. To set it up on for AM, you want a resolution bandwidth of 300 hertz. You want to get down to 300 hertz to really see this, see the spectral regrowth properly, and you don't want the video bandwidth any higher than 1 kilohertz. So 300 hertz, 1 kilohertz on the video bandwidth, and then what you need to do is you do an average. When you take a look, when you're going to take a snapshot, you do an average. Plus or minus 40 or 50 kilocycles, or kilohertz. I'm showing my age. What you need to do is you need to take 50 average. You need to let that thing sweep 50 times and average it.
Oh, okay. So the spec AN is set for average, not for peak, like you would do with an NRSC reading.
Right, because the HD AM signal and the HD FM signal is a spread spectrum carrier type of system. So those carriers are all over the place. You need to average it and let everything settle down properly. So you set it to average. So you have to let it average, and to let it average about 50 sweeps takes a good 10 minutes at 300 hertz resolution bandwidth. You do your reading, and then you make an adjustment on the exciter. For those who have set up AM stereo in the past, the way you got those loops closed and everything else, it was pretty much what you were doing is you were setting the timing of the left minus right, which was the phase modulated component, and lining it up with the left plus right, because the modulator and the RF stages in each transmitter would be slightly different, and when you change tubes and such, they'd be different. It's the same idea with the HD radio. You're kind of lining up the phase and the amplitude modulation, and what happens is this area called spectral regrowth, which actually is a reflection, and it's a function of the modulator bandwidth. It's also a function of the antenna bandwidth, and of course, if those are correct, you're going to get that to come right down. Now, if you come to a certain place and you can't get it where you want it to be, and you want it to be less than, or you want it to be greater than minus 65. So you want it
that
lower
much
than
below
minus
carrier?
65. Yes.
Wow.
And if you can't get it there, then you have to start looking at the antenna. You have to start looking at the modulator of the transmitter. The easiest way to do that is to fire the transmitter into the dummy load. If everything falls into place, you've got a problem in the antenna system. If it doesn't fall into place, you've got a problem in the transmitter that you need to look at and address.
That is just amazing how the whole system, and this is for FM transmitters too. You know, usually I tend to think of FM transmitters, coax, and antenna as being a bit less of a system of, even though it is, than AM is. So the AM, little changes at the tower or towers really can have an effect on the transmitter's performance. Now it can with FM too, but FM just seems easier. I know a guy like Gary Minker, who's a consultant on antennas and proper matching, would probably disagree. But my own experience has been that, man, AM is just difficult because everything matters a lot.
Well, and part of the reason for that is because of the low frequency. You know, when you're setting up an antenna system, especially a directional, if you're setting it up at the upper end of the band, if you're setting it up around 1500, 1600, 1700 kilohertz, it's a lot easier to get the get the bandwidth where you want, and to get things to fall into place. At the low end of the band, plus or minus 15 kilohertz is a pretty high percentage of 710 kilohertz.
Yeah.
And you know, basically you're taking that thing and you're stretching it, where you don't have to stretch it quite as far when you're at the upper end. In FM, 88.1 megahertz up to 107.9 megahertz. Yeah, there's a difference there, but the percentage isn't all that great, where you go from 550 to 1700 and say plus or minus 15 kilohertz, 30 kilohertz bandwidth. It's a much higher percentage of the carrier frequency at the lower end than it is at the higher end. Therefore, it's harder to make everything coherent over that 30 kilohertz bandwidth that you're looking for.
Here's the thing, though, is I think one of the issues we've seen with HD is that a lot of times with FM, for analog FM, just throwing it all together generally works. You get a antenna tune for your frequency, you buy some transmission line, you hook everything up, you turn it on, you're good to go. And generally, that's the case, and it works fine. But what we're finding with HD is that's not the case. That oftentimes, just like with AM, the transmission system has to be running at peak efficiency and peak performance for HD to pass right, and to not have problems with spectral regrowth or carrier encroachment on the analog signal, things like that. And they're finding that there are some cases, I want to say maybe San Francisco, where there was some interference going on, and it simply just took changing the tuning on one of the feed lines and using a section with paddles in it to change the tuning a little bit in the line, eliminated the interference problems with HD. So the one thing that I stress a lot with these installations is even with FM, if you want it to work right, take your time and make sure that everything is the way it should be even before you start, and don't take anything for granted.
I know I've mentioned him before, but a friend of mine, Gary Minker, was a speaker at the SBE here in Nashville a few years ago, actually. But he gives a terrific talk. I need to have him on here as a guest about some of the strange anomalies that go on and some of the good standard operating procedures and good engineering practices there are when dealing with FM antennas and how they need to be really fine-tuned. Just like digital television TV antennas need to be fine-tuned to really finely match the antenna and the coax or the waveguide, whichever it may be for the TV installation. It's important for FM too, especially when you get into this digital age of transmitting carriers that if there's a little mistake in how they're getting transmitted, it can make a difference between picking the HD signal up 5 miles away or 50 miles away. So it really can make, it's not just a matter of the RF being there, it's got to be there in the right phase at the right time. And those things are all affected by, group delay and reflections and things that the transmitter may do with reflections, as in the spectral regrowth. Hey, we're going to pause for a minute, and when we come back to the show, Chris Tarr is going to be talking about the Chris Tarr network. I think it's probably got a different name. And Tom Ray is going to titillate us with sexless connectors. So you want to stay tuned for you want to stay tuned for that. Hey, this episode of This Week in Radio Tech is brought to you by the folks who I work for. One of the companies is Omnia Audio. Now, here's a big announcement that you may want to be aware of. You probably will. For 10 years now, you have been aware of and hearing of and seeing the Omnia 6 audio processor. Started out as the Omnia 6 and then the Omnia 6 EX when some features were added to it that let you do HD processing in the same box for the same price. And the Omnia 6 EXI, which added the 10-second diversity delay in the box, so you could accomplish that in the processor if you wanted to, and also a low IMD low IMD clipper. Well, here's the big announcement. The Omnia 5 and the Omnia 6 are no longer available. They are on the history shelf. They're on the shelf of history. There are just too many parts in the Omnia 5 and Omnia 6 that have gone unobtainable, and they're in short supply and small quantities. So the folks that I work for, Omnia, have shipped about 5,000 Omnia 5 and Omnia 6 processors, and the vast majority of those are still on the air in stations around the world. AM service, I know there's a bunch of Omnia 5 AMs on the air in New York City on big 50,000-watt AM stations. And, of course, the Omnia 6 is on every major tall tower around the world in Taipei and Paris and New York and Seattle, just all over the place. You'll find the Omnia 6. Well, guess what? You can't buy one anymore, at least not a new one. You may be able to cajole a friend of yours into buying a used one, but you can't buy a new one. So what's left in the Omnia line then? Well, there's the Omnia 1 processor. That is a heck of a little performer for typically street price under $3,000. The list price is $32.95 on the Omnia 1. And it's available in an AM version, FM, multicast for doing streaming processing. In fact, the TWiRT network is using one right now for the recording of the audio that goes into all the podcast versions. And then there's the Studio Pro version, which is meant for professional recording. So that's the Omnia 1 line. And I'll take just a moment and remind you that the Omnia 1 FM has a free upgrade available now to the 5-band version. It's absolutely free. If you own an Omnia 1 FM, you can go onto the Omnia Audio website to the download section and the software section and download the 5-band software, upload it into your processor, and you've got a processor that's better than you paid for. It's got 5 bands of processing now and still the same price. So there's the Omnia 1. Coming out, shipping around October the 1st is going to be the new Omnia 9. This is the processor that's designed by our good friend and colleague Leif Clayson. You may know Leif Clayson. He's done some articles and a lot of talks and come out with really cool software for FM processing on your PC. Well, we've collaborated with Leif to make the Omnia 9. It's got a feature list as long as your arm, and when it's closer to coming out, we'll talk more about it. And then there's the Omnia 11. I kind of refer to the Omnia 11 as a one-trick pony, but oh, what a trick. The Omnia 11 is now on the air in many major markets around the world. And folks just aren't taking it off. It is just absolutely awesome. In fact, there are several major markets in the U.S. where an Omnia 11's on the air, and several competitors have reached into their pockets and got one too. The Omnia 11 with extremely low IMD distortion, so you can process the heck out of something and have it just sound so clean and so beautiful. So check them all out. You got the big news now. The Omnia 5 and 6, sorry, they're no longer available. The Omnia 1, off the shelf now. Omnia 9 coming in October, and the Omnia 11 also shipping now with version 1 release software. Check it all out at omniaaudio.com, and I would appreciate it if you'd go sign up for that catalog. You see that Now catalog right there in the right-hand portion of your screen, lower right there on the website? Click on the sign up for that, and you just fill out a little form. You can unclick the selection to get our e-news if you like, but it's just once a month, and it's really useful stuff. And we will send you this gorgeous, it's kind of like a Sears wish book catalog from Telos, Omnia, and Axia. I would appreciate if you go fill that out and get you a free catalog in the mail. Besides the catalog stuff, it's got some white papers and articles in there, too. So check it all out. And thank you, Omnia Audio at omniaaudio.com, for sponsoring This Week in Radio Tech. All righty. Let's get the... well, let's save the titillation for last. Can you wait, Tom Ray?
Sure.
Sexless connected? Okay, all right.
Not a problem.
Chris Tarr, you've been working on a really cool project, and I know you've put an enormous amount of work into this thing, thought and preparation, and then execution, and I don't suppose you had any troubleshooting when it was over. Tell us what you've been
doing. Oh, you're funny. All right, well, the backstory is, we have the big, we don't have it, but our competitor has the big 50,000-watt news talk station in town, and they had a sports show with a host, and sports really isn't their thing, and his contract was up, and they let him go. So this superstar name became available, and we were talking with him, and we were trying to figure out a way to leverage, all the stuff that this guy can do. I mean, he's a fantastic host and well loved, and this 50,000-watt signal covered the entire state. So we kind of put the feelers out and realized that we really could syndicate his talk show to other sports stations around the state. And so we started entering into talks to that, and I was kind of kept aware of what was going on. And right about the second week in July, I get called into the boss's office, and he says, "Hey, we got the deal done." I was like, "Well, that's fantastic." He said, "Yeah, we're going live August 1st. We need to have a network put together for him." So after I got up off the floor, I figured out how we were going to do this. And typically with networks like this and talk shows, you do it over satellite. Mm-hmm. An ISDN connection to the uplink center, and they go over the satellite and they downlink to the different affiliates. And we currently have 5 or 6, and we will have 10 before the end of the year for sure, and more afterwards. So it certainly would be big enough to support something like that. But we started to think about it, and I started to think about it. I went, you really don't need satellite anymore. Internet connectivity and the internet codecs have gotten so good now that really, what's the point of bothering with satellite? It's expensive, and it really just doesn't, in a lot of cases, make sense. And in our case, I didn't think it made a lot of sense at all. So we decided to offer the program 2 ways. One was live streaming through using a barracks system. And the higher model barracks boxes, I believe we're using the Xstreamer 1000, are fantastic. You can have multiple clients connect to it, and you can leave the connection up. So, the clients are connected all the time. They carry relay closures, so we can trigger breaks remotely. And, so that was one way we're doing it. And then we also made the program available for download. So we would take the audio and record it. We edit it and put it up for download so that stations that want to ingest it into their automation system and play it back later can do that as well. Well, the first issue with all of this was, that part's easy. Putting in a streaming box and setting up a computer, which, by the way, my IT guy found a great Linux program, and unfortunately I can't think of it off the top of my head, but is essentially a free audio logger that runs in Linux, and that's what we're using to record the show. But okay, that part's easy. That putting hardware in and hooking it all up, we can do that. The issue is that the affiliates need to get clean audio. So they need to get audio from our studio without our commercials. They need to be able to put their own stuff in. Well, I needed to have something that could do that was easy to run for the person in the studio, because typically when you have a network show, you have a network studio, and the operator sits there and he plays the intros and outros and things, and then during commercial breaks they do nothing because the affiliate stations fill with their own commercials. Well, we're also running the show live at the same time, so this is where it gets kind of clever. I sat there thinking about it, and I said, well, why can't we just make ourselves an affiliate of the network? So what we did was we set up our automation system to run in satellite mode during this program, and I put a big red button in a box. And I said to the person running the show, I said, whenever you need to take a break, start the show, end the show, press this red button. And what it does is it sends a closure to our affiliates, but also sends a relay closure back to our system to trigger breaks. Now, here's what's so fantastic about it is with our automation system, like many, if you say in satellite mode that we have to fill 3 minutes, it will fill exactly 3 minutes. It'll overlap commercials, spread them out, do whatever it needs to do to fill those 3 minutes. It also has an audio switcher with several outputs. So if you think about where I'm going with this, what happens is during the break, the announcer presses the red button, and it turns off. It sends a relay to everybody saying, "Hey, there's a break." It also turns off the audio feed to the affiliates, so they hear silence. So by just pressing this one button, it starts our local commercials. It sends a relay closure to our affiliates, and it turns off the feed to the network so that they're not hearing our commercials. And then the script in the automation system says, "Hey, when the commercials are done, put everything back." So the commercials end, everything turns back on, and the show continues. So really in a matter of an afternoon, I developed this system with the automation to basically treat ourselves as an affiliate. And in the meantime, for this entire program, the only thing that the guy who's running the show has to know is this red button. Push the red button. So we tested all of it out. It was functioning great. I'd press the button. The brakes would trigger, the relays would get done on the other side, and fortunately, some of our affiliates are co-owned, and their engineer's an old friend of mine, and so he and I would get on the phone and we'd do these tests, and he was very helpful in working with me to do it, and everything looked great. So we're like, okay, here we go, we're ready. The big day comes, everything's working the way it's supposed to, and we get to the end of the show, and there's a wrap-up email, and I get an email back from our affiliates and said, "Yeah, the show is great, except we didn't get half of the relay closures we were expecting. You guys kept going to breaks, and we weren't getting any closures."
Oh.
Yeah, I was stunned. We tried this thing over and over and over, and it was working fantastic, and we couldn't figure out what was going on. So we go back and we look and we do some digging. Well, it turns out that the guy on the air who's pushing the red button would just do a quick little click on the button. And that was enough to close the relay on the streaming boxes, but it wasn't enough to translate that on the other end as a closure. So we would send the relay, it would see it on the box, but there just wasn't enough of a closure there for it to decode on the other end.
Ah, okay.
So, okay, great. So we have we explained to the guy, okay, now, press and hold the button when you need to do a break. Well, that's not really an answer. That just, you're hoping that this guy's going to remember to do that. And if he doesn't, you're going to have affiliates that are really angry.
You've got a bunch of people thinking the same answer right now, Chris Tarr. Eric Adler in the chat room used the right word. I couldn't remember the right name, but Eric Adler says a monostable multi-vibrator. Is that how you solve the problem, or did you do it some other clever way? I
used a time delay relay. I went online. And you can get these fantastic relays that they're fairly big, and they have a time adjustment on top. And all they take, they have, unlike a typical relay, this relay, you feed voltage to it constantly, and then the other side is a closure. And when the two contacts close, it holds the relay, and it holds it for whatever time you want it to hold, and then releases. So all I did was I took out the button, the direct connection into the streaming box, and ran it through this time delay relay and set it for 2.5 seconds. So even if you press the button, just tap it, it holds and holds for 2 seconds and then releases. The other upside of that is if somebody gets trigger happy and presses it 3 times or something, it only holds it open for the one time. Yeah. So we solved that issue. But really what was interesting is this whole time I had 18 days from start to finish was getting together with the host, getting together with the programmers, getting together with the general managers of all these stations and the engineers, and really we all kind of had the same goal. We wanted this show to succeed, and we wanted it to go off without a hitch, and we all worked really hard together and really closely and said, okay, let's step through all of these possible scenarios. Okay, most stations are actually recording the internet stream and then playing it back later if they're not carrying it live. So we provided the FTP as a backup to that. Okay, let's say the internet goes down, which is, I have several T1s coming into the building, so we've got plenty of capacity. But what if that happens? Okay, well, we've got the FTP server available, and we record all the shows and edit them and have them available. We put in an ISDN line. Okay, if one of you has a Barracks box that doesn't work, we can do it through ISDN. But, what's interesting is I think the total in terms of the equipment that we needed to put this network on the air and feed our affiliates, I believe the total came to it was like $1,500. And
Yikes.
with $1,500, we were able to put on a network that right now is feeding 5 radio stations. The computer we already had, the Barracks box. I can't say enough great things about that Barracks X streamer. It's $500, and we're feeding 4 affiliates right now off of that one box, and the audio is fantastic on the other side, and they're getting relay closures. It doesn't take a lot of bandwidth. So literally $1,200, we put a network on the air with this guy, and it's been running now, since August 1st, and we haven't had, other than the button pushing problem, haven't had a single problem with it. But it took us to think outside the box with it. Oh, sorry, I heard something in my ear. It required us to think out of the box to put it together, because the easy solution is put in an ISDN line and call an uplink provider and put it on the satellite and have all of our affiliates get satellite receivers. That's typically how you do it. And, we thought of it differently. Went, well, really we could do that, but, technology has changed so much. Is there maybe a different way we could do this that seems a little more efficient? And, nowadays with internet and bandwidth being so cheap and big red buttons, we can make that happen. And by the way, the great story about the button is I literally went online and shopped for about an hour to find the right button.
Now I went down to Staples and I got a big red button right here. So.
It is literally a project box about that big with a red button in the center with a flip-up cover, because I didn't want people who, before and after the show hitting the button and triggering. So it actually has a safety cover on it. You have to flip the cover up to press the button, and it's in this big black project box. And, very nicely, I mounted it in there and did the whole thing. But, we laugh because it does. It looks like a self-destruct button. It's just a big red button. But,
Hey, Chris, Chris, I just have one thing to say.
No, not the wet one. Don't ever push the wet one.
That's true story. We were getting ready to go on the air. 5 minutes to air. The guy running the show pokes his head out the door and yells, "Hey, Chris, what's the red button do?" I was like, right before we start the show. But radio humor, you gotta love it. But it really was. It was, it was just a very rewarding project in that we did it in a short amount of time. We did it relatively inexpensively. We did a lot of things that normally you wouldn't think of. We really kind of went outside the box, and instead of saying, well, this is how we have to do it because this is how everybody does it, we said, well, what do we need to do, and then worked our way backwards. And, in the end, everybody's happy. We've got this show on that's working really well. So a lot of fun. It was really a great project and a really good learning experience for me. I had never done anything on that scale before. So it was pretty cool.
Chris, what Barracks box do the affiliates have at their location?
They are using the Xtremer 1000s as well, simply because I believe that's the cheapest version you can get that has the relay closures on the other side that can be received.
Okay.
But the interesting thing is that you really don't, the way I have it being fed, if you're just recording it for later use, you really don't need the relay closures because I send silence in between the segments. So, you can set your automation system to stop and start on audio and get recorded as well. And that was the other thing is, I set it up in a way so that there's several options for affiliates to record this thing if they want to, either by silence or by relays. But more importantly, the guy on the air, all he has to remember is this red button. It starts the show, it starts the breaks, and it ends the segment. And it's just the one button. And depending on the time of the hour, it does different things, and I do that all in software. So in doing that,
do you send the same closure to the affiliates, or does the one button control different closures depending on what is happening at that moment?
The button actually controls two different things. It sends a closure to the affiliates, but it also sends a closure to our automation system, which then also does different things based on what I have the software telling it to do.
Okay,
so for example,
the affiliates get one closure, right?
Correct. Affiliates get one closure, And what we do is based on the time of the hour. For example, you push the red button in the middle of the hour and it plays breaks. You push the button at the end of the hour and all it does is turn off the audio. You press the button at the beginning of the audio, it turns the audio back on to the affiliates. So, depending on that, what the affiliates hear will be dependent on the time of the hour that this button is pushed. But even then, there's more things I could do with that because our automation system also has outputs. So I could actually let the switching system take the closure and do different things as well. So, there's a lot more that we could do down the road if we need to. But in terms of just getting it on the air and starting it, it's very easy to use for the operator. It's pretty foolproof for the affiliates. And, there's not a lot of complication there, which reduces the amount of errors that we run into. Now, for example, if we had to do it on a large scale where we're doing drop-in IDs and all these other things, that'd be a little different story, but it's a regional network and, working really closely with our affiliates, we've designed a way for them to receive the show where they can customize it without making it too difficult for us to do that. So it was real interesting. And again, it took a lot of work from everybody involved. It wasn't just me saying, well, let's do this. We're going to do it this way. Some of the ideas came from some of the engineers from the affiliates. And I said to, I'd have meetings with their programmers and their engineers and said, well, we're going to start running this. What do you need? What is it that you need to make this show happen? And they'd give us feedback, and I'd incorporate that in the design of the system.
I'm surprised the affiliates didn't tell you that they were accustomed to getting typically 2 or 3 different closures, since so many networks send a one contact closure for the beginning of a break, a different closure to rejoin the network, and then oftentimes a third closure for the top of the hour ID.
We've found, and just from our own experience, oftentimes you don't need that many. I mean, that's a hold off from a lot of other, old systems where you're firing carts at those relays and that sort of thing. True story, back when we were running Delilah sends 11 or 12 different relays in an hour. I'd boil that down to 4. I using all of those relays, combining it to 4, using my automation system to determine what to do with those closures based on the hour. Automation systems now are so advanced that you really don't need more than 1 or 2 different relays to make it happen, because you can say, when you hear the relay between this time and this time, do this. When you hear the relay at this time, do that. So, you can really take one relay and have it do the function of 3 or 4 different relays, again, if you set it up correctly. And, I checked with all of our affiliates and saw what automation systems they were using and saw their capabilities and sat with them and said, okay, here's how you need to set yours up for this to work. And so far it's worked great.
By the way, is your talent, this highfalutin, fancy, high-paid talent, is he there at your facility at the where the show originates, or is he off somewhere else in a remote studio?
No, he's at, and that was part of why I had to do it this way, is he's in our facility most of the time, which means that not only are we having to run his show, but we're having to originate his show from the same studio. And that's what makes it difficult, because we have our own spots to play, plus we have to be mindful of what's going out to our affiliates. So that makes it even more difficult, and why I had to kind of set up our automation system to act as if we were taking a satellite show. And really the guy in the studio doesn't do any manipulation of the automation system or anything. It just runs in the background, and he just pushes this button to make things happen. But we did put in a Telos ISDN box. We also put in some other devices so that he can really do his show. He has done his show from affiliate stations. For example, we have the Packers here, obviously, and one of our affiliates is in Green Bay. So during training camp, he'd go up and do a show or 2 from there. Again, based on the way the system works, he can do the show there. All we need is his voice coming to our studio and the big red button with the operator there. So, we can run the show from pretty much anywhere as long as we're able to get that one button closure to make it all work.
How come the talent himself doesn't have the big red button?
I don't know that I trust him with the big red button yet. I don't know him that well. So I'm not sure I want to give him that much control.
Because, you know, if he's doing the show remotely over ISDN with a Telos box, you can give him the big red button, carry that closure right back to the station. And
well, that's one of the reasons why we picked that. And we did buy a separate Comrex access box for IP, and that's simply because we already were ingrained with that with some other stuff.
Oh, yeah,
but
sure.
The Comrex box does the same thing. We can send the relay closures that way, and we have talked about that. You know, once we get this done and perfected, then we'll look at moving. You know, being able to move the big red button wherever he's at, and control it from there, and take it one step further and make it even easier for us to do. So, it was really kind of designed that way. Again, it was a very low cost way to create this network. We have 5 or 6 affiliates. Again, on if you're looking at just the delivery system, $1,200 or $1,300 worth of stuff for a delivery system. So I mean, it's a whole new world in terms of syndicating programming.
You're saying it's affordable for almost anyone at this point.
It is, and that's somebody mentioned in the chat room. It sounds like a moneymaker, and it really is. Just on that, I mean, the cost of operation. For example, when he was broadcasting from our affiliate in Green Bay, we used an IP codec on the way back. It cost us nothing for him to be there to do his program.
Sure.
The recurring costs are nothing. We don't have to pay for satellite airtime. Obviously, we pay for bandwidth, but we use that already. We're already paying for that. So the delivery system costs us nothing.
If you had 500 affiliates like Dave Ramsey does, for example, or a Sean Hannity or a Rush Limbaugh or a Dr. Laura, well, I guess not Dr. Laura anymore, but if you had that many affiliates, you'd need a different distribution method, wouldn't you?
Oh yeah, I mean, the downside to this is it doesn't scale super well. I mean, you could. I mean, if you had the bandwidth, you could do it. The streams themselves are very, very small. I mean, we have again with the affiliates we have streaming, they're connected 24/7 to our network, and we can't even tell they're there. So you could scale it fairly large before you'd have to move on. But at that point, when you're looking at 1,000 affiliates or something like that, you'd want to go with satellite delivery. But we were looking at this is really a Wisconsin-based show, and it's about Wisconsin. So, that's never going to be the situation with us. We'll probably have 10, maybe 20 affiliates across the state, and that's going to be it. And I'm pretty confident that we can support that just simply using IP.
Gotcha. Cool. Hey, before we get out of here, Tom Ray, you got a quick story for us about a sexless connector.
Yeah, but
what
first
are
I
you
want to
talking?
say...
Quiet, numbskulls, I'm broadcasting.
But anyway, that was a request from the chat room. Anyway, and actually, before I get into that connector real quick, I'll just tell you a quick story about a button. An engineer I know, one day, they put up a 4-tower directional array. They had a station that was single tower. The tower was right next to the building, and the day they were going to turn the 4-tower directional on, or not turn it on, they were going to take down the single tower next to the building. They were just going to cut the guy wires. So he went downstairs where the studio was to the jock who was on the air and said, whatever you do, don't press 8 lower on the remote control because the tower will fall down. And the guy, yeah, right. And continued on his show. Of course, he went outside. He said to the tower crew, he says, knock yourselves out. They cut the guy wire. Tower fell. He went screaming downstairs, yelling at the top of his lungs, what did you do? You pressed 8 lower. And the jock says, what do you mean I pressed 8 lower? He said, the tower fell down. The guy looks out the window. The tower is flat on the ground. And, I didn't press it. Honest to God, I didn't do anything. Oh. But anyway.
All right.
So we're talking connectors, and actually we didn't talk connectors tonight, but I got this sexy little connector here.
I thought it was a sexless connector, not a sexy connector.
Well, it's a sexy sexless connector.
All right.
Many moons ago, General Radio made test equipment for broadcasters. Matter of fact, I've still got a General Radio test oscillator that we use at WOR with the antenna system, and they had an interesting connector system. Matter of fact, I've got an adapter in my hand here, and the only reason I have this is when Channel 2 television here in New York, WCBS TV, signed off. They had to get rid of their transmitter, and they had all these wonderful power modules that are a kilowatt. It's basically a big block that does a kilowatt. And they didn't know what to do with them. It's expensive to get rid of things like that in New York City, and they were getting rid of the transmitter. They couldn't sell it. Nobody wanted it, so they gave them away. So I've got a couple of power blocks here. And on the back of that power block, and what I'm going to do with it, channel 2 is 54 to 60. Yeah, 54 to 60 megahertz, give or take.
That'd be 6 megahertz. Yeah.
That's the television channel. Well, the 50-meter ham band is 50 megahertz to 54 megahertz. So these things won't be that difficult to tune down.
Yeah.
But I was looking at the connector on the back, and I said, man, that's kind of unusual. And then I realized what it was. It will mate with a general radio connector. And the adapter I have in my hand is a GR874.
We're all waiting to see it. Can you hold it up to the can?
On this side, it is a regular, standard UHF connector.
As in I call that a PL259, but yeah, that's a UHF.
Right, exactly.
Even though it's no good for UHF, it's
right. It's great for
UHF
VHF, but
Yeah.
not UHF. On the other side is this sexless connector, and if you look at it,
well, it looks
it
female.
looks kind of like a PL259. It looks like a female, but if you take two of these, and you plug them together, they fit together.
Oh, okay.
And you don't have to say, I have to have a cable with a male, and I have to have a cable with a female on the other side. You just have two cables with these connectors on, put them together, instant connection.
Uh-huh.
And on the older General Radio test equipment, all of their test leads were terminated in these, and this is exactly what you saw on the piece of test equipment. So it didn't matter what you had. You just grabbed this thing, you plugged it in, you were done.
Does that connector have a name or a designation?
You know, I'm not quite sure exactly what the designation is, but this one is a GR874, and if you look it up on the internet, it'll take you into. There's actually a whole history on this connector and why they built it and how they built it and what it does and the fact that you can plug them together, and it's a very interesting set of articles I read, and you know, this is a whole series of GR connectors. I mean, they have adapters, they have just this side, they have chassis connectors, they have cable connector. You name it, they have it.
Oh man,
But
yeah,
they're hard to find.
You Google GR874, and all kind, and there's a whole Wikipedia entry on these connectors. That's pretty that's pretty interesting.
It's a very cool connector, and the sad part is I haven't seen one in years until I got one of these amps, and I looked at the back and I said, that's a GR connector. And there is one company actually that does make these. It's not General Radio. They're hard to find. Matter of fact, not this one, but I bought a second one, so I had a second adapter. I bought it for $10. Wasn't that expensive. So,
with the Wikipedia entry gives the advantages or the desirable properties of these connectors, and one of them is hermaphrodism. So there are no male or female connectors. Any GR connector could mate with any other GR connector. Well, how about that? And they were reliable too, it says.
Yeah. So yeah, it's a great little connector. I mean, it's a marvelous little thing.
Right. What a way to end the show. That's called the kicker story. The General Radio 874 sexless unisex hermaphrodite connector.
And now, page 2.
I think, and now we've come to the end of our story for today.
And now you know
Wow, okay.
the rest of the story.
Anybody have anything else to add? How can you add to that?
You can't.
I don't know. Yeah, you can't. You can't. Hey, Tom and Chris Tobin, who couldn't be with us this evening, and I would all appreciate it if you would tell your friends about This Week in Radio Tech. Tell your geek friends, your radio engineer friends and your ham friends and such about This Week in Radio Tech. We're easy to find on the web at thisweekinradiotech.com, or I would suggest you check us out at the twit.tv website. If you go to twit.tv/TWiRT, that's TWiRT, twit.tv/TWiRT, you can watch shows, listen to shows, you can subscribe to shows, and download them right from there. I'd appreciate it if you'd get a subscription. Just download it to your iTunes or your other feed software every week, and that way you'll have it right there on your computer. You'll get it every week, and our numbers will look better, and we'll appreciate it very, very much. So thanks for listening, and thanks for watching to This Week in Radio Tech. Chris Tarr and Chris Tobin and Tom Ray, all them and me, most of us will be back next week. We might have as a guest next week too, so hope you'll stick around for that. And hey, thanks to all the folks who congratulated me on passing the exam for my General Radio amateur general license. There you go, something like that. I haven't gotten the paperwork back yet, but I did pass the test, and a big thank you to the volunteer examiners in Petaluma who helped me out with that. And
don't forget, Kirk, if you have that CSCE in your hand, all you have to do is get on the air, give your call sign, and say slant AG. And
that's
you can
right.
Use the general class stuff right now.
That was even a test question. What do you say at the end of your call signs? Slant
There you
AG.
go.
There you go. I was going to say, slash or /AG, but no, it's slant. And Gordon West will tell you so. If you're interested in ham stuff, of course, we talk about that from time to time here, but also you might want to check out the Ham Nation show right here on the TWiT Network. Okay, that's it. We got to go. Thanks to Omnia Audio for sponsoring the show. Go to telosalliance.com/now and sign up for the free catalog that you can get from Omnia and Telos and Axia. And thanks again to Omnia Audio for sponsoring the show. We got to go. We'll catch you next week on This Week in Radio Tech. Bye-bye, everybody.